All right, welcome back. We're going to talk about series circuits today. Series circuits. Specifically, we're going to dive into voltage, resistance, and current within a series circuit. We've learned about those three ideas or concepts before this lab, and so we're going to explore them more today. So the question today is, what happens, or the first question is, what happens to voltage drop in a series circuit? So we have three light bulbs here. I'm going to first start out and make them all have the same resistance of 10 ohms, so 10, 10, you see on the bottom, and we'll make that 10 ohms. So we have the same resistance. We have a 9-volt battery. So what happens to that 9 volts? Well, it turns out in series, a circuit where, in this case with 3 bulbs, you have to go through one bulb before you get to the next bulb, before you get to the next bulb. There's no other path. That the total voltage drop in a series circuit is split between all of the resistors that are there. So 9 volts would be split between these 3 resistors. How is it split? That is a big question. So if all the resistors are equal, you see in the green box, if they're all equal, which they are in this situation, the voltage drop will be split equally. So I don't need to use Ohm's law for that. If I have a 9-volt battery and I have 3 bulbs or 3 resistors, 9 divided by 3 means that each of them gets 1/3 for a total of 3 volts of potential drop. So that means that you start out with a 9 volts of electrical potential. You lose 3 across the first, 3 more across the second, 3 more across the third, and then you have to go back to the battery to recharge. 3 plus 3 plus 3 is 9. You would not get a value, the piece parts would not give you a value bigger than the total from the battery. Now, what if resistors are not equal? So I'm going to make this a resistance of 5 ohms. This one is going to stay at 10, and this one is going to become 15. We'll learn in a future video why I'm choosing those specific numbers. There's a reason. So if you have this, where the voltage, the resistors are not equal, that means that the voltage drop is not, see in the pink box, not shared equally. You would actually need to use Ohm's law. Yes, you have to do some math to determine the voltage drop across the 3. Now, if you added the voltage drop across each of the 3, it would end up being equal to 9. But how much does each get? So in this example with 3 bulbs, a 5 and a 10 and a 15 ohm 9-volt battery, it turns out there's 0.3 amps of total current. Well, you see the math here. Across the 5 ohm resistor, you get 1.5 volts of potential drop. Across the 10 ohm resistor, you get 3 volts of potential drop. Across the 15 ohm resistor, you get 4.5 volts of potential drop. And if you add the 1.5, 3, and 4.5, you get 9 volts, which you'll notice is the potential difference provided by the battery. So in this case, where the resistors are not equal, the voltage drop is not shared evenly. So also notice that the higher bulb with the higher resistance has the higher voltage drop, and in turn, it is brighter. And we can prove this if we took the voltage leads. We'd say that, hey, there's 1.5 volts loss across the first, 3 volt loss across the second, 4.5 volt loss across the third. So we just proved experimentally that the math is right. Now, what if instead of talking about voltage, we now wanted to talk about current? Well, it turns out current is the same throughout the entire series circuit. So you see that it's 0.3 amps through this entire series circuit. So why? Why is current the same through an entire series circuit? Well, there's only one path to go. So if you think of water flowing in a single pipe, there's nowhere else for the water to go. So the flow rate is the same at every point in the pipe. In fact, it's all or nothing with the current. So if I broke this circuit right here, there would now be no current.